Hello and good evening, ladies and gentlemen. My name is Mohammed Mubarak Salman Bayashut, and I am currently taking Electrical and Electronic Engineering at Management and Science University MSU. Here is my supervisor, Dr. Safa Najah Saud Al-Humairi, and this is my FYP project entitled Magic Mat Design a Smart Power Generation System using Piezoelectric Mechanisms. So, no one denies the importance of electricity nowadays, especially with modern technology. There are massive quantities of electrical energy is being consumed every day. On the other side, the world's leading source of emissions and pollution is through electricity production. Besides that, the world's population is continuously increasing, creating a great gap between the demand and supply. Therefore, the scientists are looking forward for new alternatives for power generation using renewable energy resources and their feasible applications. Hence, my simple solution for this problem is by implementing a smart power generation using piezoelectric mechanism, which is going to be implemented in crowded places in order to convert the applied load into electricity or energy. I have three main objectives for my project. First, to design a clean and affordable power generation using piezoelectric pressure system. Second, to embed the designed pressure piezoelectric system into a walking mat called Magic Mat. And third, to measure and monitor the power generated using blank mobile application and LCD screen. Next, review of related literature. Here are the important researches that I have found during my research regarding piezoelectricity. Number one, footstep electricity generator using piezoelectric sensor. This is the basic principle of piezoelectric by applying two tiles and the piezo sensor in between. So once they are pressed, the piezo sensor is going to convert the convert the applied load into electrical energy. Second, design a cantilever piezoelectric power generation device for real-time road safety warnings. This research can be implemented in highway uh, in order to allow the cars to press the piezoelectric sensor, so the piezo sensor can convert the applied load into electricity. Number three, footstep power generation using Arduino Uno. This research is much more sophisticated because it is using Arduino Uno to monitoring the output voltage generated using LCD screen. Next, summary table of the related literature. Here are a few researches and products with their advantages, disadvantages, and remark. Number one, piezoelectric energy harvesting from pavement. The advantage, it investigates in different piezoelectric types and different designs. However, the system provided doesn't use a monitoring process. The remark, it differentiates between batteries and supercapacitors for storing energy. Number two, design a cantilever piezoelectric power generation device for real-time road safety warnings. This research is a kind of unique because it is being implemented in the highway or on the road, which is going to tolerate much more applied load. Disadvantage, there's no batteries being used and the energy is available only while the car is passing. The remark, it profiles output voltage in normal speed car. Number three, a review on energy harvesting from ocean waves. The advantage, it provides different methodologies for ocean wave energy harvesting. However, The circuit used is very basic and no novelty or no monitoring process. The remark, it discusses in details the mechanism of each methodology. Number 4, design of a pavement using piezoelectric material. This research studies the structure of piezoelectric and studies the connection for sensors. For example, either they are in parallel form or in series. The disadvantage, however, a few tiles were used and a little output energy being generated. The remark, more conductive materials were better to be used. Number 5, which is my project, Magic Mat design a smart power generation system using piezoelectric mechanism. The advantage is to provide online and offline monitoring system, online using mobile application, blank mobile application, and offline using LCD screen. Besides that, my project is a zero pollution and requires no maintenance and provide a complete circuit diagram to build the project. This advantage, however, is big size, which is in fact advantage because bigger size will provide higher output energy. The remark is going to provide energy to charge smartphones and LEDs and so on. Next, research methodology. In my project, I used system development lifecycle approach, which is mainly have 5 phases: requirement analysis, design, implementation, testing, and evaluation. Number 1, requirement analysis. The planning process is being implemented by determining the problem statement and analyzing project background. For the design phase, we have to determine the project features according to the background. Implementation, we have to implement the prototype, a real prototype, and before that we have to simulate the project using a SolidWorks program. Testing, we have to test the prototype and make any adjustment or amendment to the project if needed. Evaluation is regarding the project review which comes from the users or customers. Next, flowchart and block diagram of the project. Flowchart shows the process that the project undergoes, starting with the piezoelectric sensor, which is going to generate electrical energy, then going to the AC-DC rectifying process in order to convert the AC voltage into DC, then goes directly to the charging process in order to store the energy in the battery, in the 12-volt rechargeable battery. Then the Arduino Uno will go into keep monitoring the power generated in the energy and send the data to the blank mobile application and LCD screen for monitoring process. On the other side, we still have the output energy as DC load. For the block diagram, it goes with a similar process, starting with piezo sensor, then goes directly to the rectifier, AC-DC rectifier, then 12-volt rechargeable battery, then Arduino Uno, which is going to connect the battery with the blank mobile application and LCD screen, and on the other side we have a multi-port DC socket. Next, hardware component. As we can see here at the right side of this slide, we have the most important components that I used during the prototype building, starting with the piezo sensor, which is the source of the energy because it is going to convert the applied load into electrical voltage. Then we have the Arduino Uno, which is the tool that's going to process the data that's being generated the data that's been received from the voltage sensor and send it through the Wi-Fi module to the blank mobile application. Then we have rechargeable battery in order to store the energy that's being generated by the piezo sensor. At the left side of the slide, we can see here the mat that I have implemented during the wiring process. I have used 114 piezo sensors that are connected together in parallel form. Next, circuit diagram of the project. As we can see here in the top of the picture, we have the piezoelectric sensor connected together in parallel form, and then connected goes directly to the rectifier and then to the battery. The Arduino Uno in the middle is going to connect connect between the voltage sensor and the Wi-Fi module in order to send the data directly to the LCD screen and to the blank mobile application. Next, the 3D design of the project. For this step, I am using a SolidWorks program in order to simulate the mat. As we can see here in the picture A, the transparent view of the mat by building two layers of rubber and the piezo sensor in between. I have implemented as much piezo sensor as I can in order to increase the output energy. Picture B also shows the structure of this mat. Next, IoT monitoring system. As we can see at the left side here, this is the mat that I have implemented and the circuit box which have the circuit component, and I have implemented two types of monitoring system, online and offline. Offline using LCD screen so the user can see the output energy generated through the LCD screen which is attached to the circuit box. The second type of monitoring system, online using Black mobile application. So it is easier for the user to monitor the process online from anywhere using the Blank mobile application and show the graph of the output energy generated. After that, preliminary results. During my data collection, I have placed my project in crowded places inside the college in order to give potential users a chance in order to step on the mat and generate electricity for a period of 1 hour. So after a period of 1 hour, the data has been extracted and the graph of voltage and power has been plotted. As we can see from the left side, the graph of the voltage that is being generated is ranging between 12 to 13 volt voltage. The second graph shows the power that is being generated around 85 to 87 watt, which is quite high compared to other products that's available in the market. Next, potential market. The potential market of my project is going to be any place that is crowded of people, such as Malaysia Airport, Rapid Care All, and supermarket. And also the estimated market value is around 500 ringgit. So, in conclusion, I would like to conclude that during this research, I have implemented a smart and affordable power generation system using piezoelectric mechanism, which is going to contribute very much to the society and community by providing sustainable electrical voltage in places whereby the main electrical grid is unavailable or unsustainable. Besides that, my project is a zero pollution and requires no maintenance. Besides that, the idea of the project is never been implemented in the Asian countries before. This is the first time that implement such kind of project. Furthermore, my prototype is very efficient. During the data collection, I figure out that the mat can generate around 1.1 milliampere per single step, which is going to fully charge a battery with a capacity of 7,000 milliampere per hour in 20 hours with a continuous step. That's all from me. Thank you very much.
This is the video demonstration for the project. As you can see, this is the final design of the project, including the magic mat and the circuit box. This is the circuit box, including the circuit components and project features. Uh, this is the mat during wiring process, showing the piezo sensors and the connection. I have implemented 114 piezo sensor. Now for the demonstration process, I have placed the mat in public place, in crowded place, in order to demonstrate. I'm placing the mat right now on the ground. Connecting the wires by using plug-in, female, male plug-in, and then step on the mat. As we can see, here is the voltage is being generated while I am stepping on the mat using a digital multimeter. Here's the potential users trying to demonstrate the project. The voltage is being generated while they are working on the mat. Here is the online and offline monitoring system using blank mobile application and the LCD screen. And this is the project features. Right now showing the features of the project, including charging USB from 5 volt and light up LED, 12-volt LED, all from the energy that is being generated in the battery.